Let's start our next lesson. Yeah, first of all, I would like to say that preparation for the last material, the last mid-semester exam was a very, very bad, very poor. Okay, next 2 weeks or 3 weeks, how much remaining? 2 weeks. I will give you more information. I will provide you more detailed information. You will get the questions. End of semester, you pass my second semester exam. I mean, the second mid-semester exam. And after that, you will pass exam after New Year. That's final exam. Final exam will be in the center, the exam center, not with me. Okay. No batches. Okay, now let's start for the new topic, which is right important on board the tanker, on board the chemical, any type of the tanker. Let's call it hazards associated with the tanker operation, static electricity, emergency operation and action, and safety management, plus MSDS and SDS. Most probably you already have learned these courses on previously, you know, which the subject, MSDS and any hazards. But I just want to remind you that is really needed for the safe operation on board the tanker. Okay, here there's some information that you can read. I already shared it with you. So the tankers can carry this simultaneously, same time, different kind of cargos. Sometimes this cargo is not compatible. Sometimes the part of the cargo you need to make heating, another part of to make cooling, and so on. So that is a different way when you will work on the chemical tanker, and most probably who will work on the tanker that will be chemical tanker, unless it's a crude oil. So you will get to manage with a different type of the cargos, and you have to think about it. Okay, not when you will be a cadet, but here we are not preparing the cadet. Here we're studying the officers. And when you will be officer, you must clearly understand what are you doing on board the tanker ship. Otherwise, you may have a big troubles. So what kind of hazards? One of the hazards is the petroleum. Petroleum is not only benzene and diesel oil. So petroleum could be different chemicals also. The first of all, the toxicity. When you can inhale it or breathe it or poisoning by via the skin, that is a toxicity. Next is the oxygen deficiency. Yeah, because of petroleum cargoes evaporating very easy with a low temperature evaporating in the air. So they are pushing out the air oxygen, and so the oxygen deficiency could be observed there. Flammability and explosiveness. Of course, that is a main reason who is afraid for the petroleum. Benzene can explode in the normal temperature. But you must understand clearly how it could explode and how to prevent it. Electrostatic hazards. Yeah, that's what we will talk today. Hazards to environment. That is what's concerning the MARPOL. Yeah, hazard to environment. MARPOL now not only pollution at sea, it's also pollution in air. Includes this subject annexes. You know about it. Okay, let's start from flammability. And what is a flash point? This question will be many times asked you by the other interviewer and by me also. What is the flash point? The flash point is the lowest temperature at which the flammable liquid, any liquid, yeah, maybe normally it's flammable, of course, yeah, liquid will produce enough vapors to form of ignition mixture with surrounding air. So flammable flash point when the benzene is evaporating so much in the lowest temperature, when I just take the fire and it will explode, so enough vapors. But this one needs outer explosion, outer fire, you know, some spark or fire or something. Yeah? So that is a flash point. Here the picture, 20% nothing, you can boil, no vapors, but 25 is more risky, and when you have a 29, it's enough vapors, producing enough vapors for the fire. Okay, next is the flammable limits. So what is the flammable limits? When you have not enough vapors, nothing will happen. You take in the room 1 milligram or 1 milliliter of the benzene, push it, evaporate it, take the fire, smoke the cigarettes, nothing will happen. It's very, very small amount of vapors. It exists in the room, but it's not enough to fire. But if you will put the bucket and evaporate the bucket in the room, that is already very dangerous for smoking there. Okay, so that is enough vapors, yeah, so that is the flammable limits. But if you have a lot of vapors, where is not enough the oxygen, so it is again safe room for the mm, any flash or sparks there. But that is the flammable limits. So let's talk about auto ignition. Auto ignition, that is the same temperature when it's producing enough vapors for spontaneous combustion without any fire. So it will spontaneously combustion by itself. So diesel, if someone has a diesel car, it's working by the auto ignition point. So the piston compress the air, inject the diesel there inside, and diesel has so much temperature there, so it's combustion spontaneous itself. Yeah. So that is auto ignition. Please remember the difference between flash point and auto ignition. Okay, here you can see this picture. You will see this picture many times. That is taken from ISGO. On this ordinate, you can see the gases, and this axis, on axis, this lowers, you will see the percentage of oxygen. So when you have a 21% of oxygen and you have 5% of gases, that is going here, and it is enough risky to fire. You know? So that is really risky to fire. But when you have low gases, yeah, 1% of gases, so that is not risky. So what you can do on board the vessel? Can you remove the liquid, reduce it up to 1%? Yes, in some cases, yes, but not always in your hand, because you need to carry the petroleum cargo. You cannot manage too much with this percentage of the carbon in the air, in the atmosphere, but you can manage with the reducing of the oxygen. So you have 5–10%, it's a risky zone of the carbon in the atmosphere, but you can reduce less, remove the oxygen from this atmosphere, and you can see the safe zone. So less than 10%, it's already safe. Yeah, so no problem when you have a less than 10%. You can feel safe. So fire you cannot remove from the tank, because it's a static electricity happens there. So many things could be happen inside in the tank, and you cannot remove all this risk from the tank, but you can remove the air, oxygen, so oxygen from the tank, you can remove it by the inerting tanks, IG, what we talked before. So inerting the tanks, and the IG with the 5% of oxygen only, less than 5%, you inserting in the tank, take out the oxygen. Oxygen is moving away, so reducing the oxygen up to 8%, 8 to 10%, but less than 8 is preferably. And you have a safe environment for loading benzene or any other explosive cargo. Why we need it? Because the number 3 in the triangular, the number 3 is a fire, we cannot escape. We cannot avoid to bring the fire inside. How it's happened inside, how it could be happened, fire inside. Nobody smoking there, nobody playing the matches there in the tank, but still there is a hazardous for the sparks. These sparks is a part of the static electricity. You see this picture? The girl, the kid come out from the tube, the plastic tube, and her ears are magnified. So they are magnified by the static electricity. This static electricity is always beside you. It's always near you when you are on board. Not only near on board, even at home, when you every full day you are working with a sweater, nighttime you remove the sweater, you see the small sparks, it's going. So that is the same way when the spark is happen on board the vessel. That is one of the most important, one of the most usually happen the explosives previously without the IG when the vessel was not used IG. It was explosive because of the static electricity. So you can see here the risk when it could happen. It could happen during loading, unloading operation, steaming, gas freeing, tank cleaning, and sampling. Let's see them one by one. So gas freeing. When you complete discharging of cargo, now you need to prepare the cargo tank for the next cargo. You wash the tank, etc. But now you need to wash it and ventilate it to send the people inside to make a mopping, to clean it completely. And you start ventilating. Before this operation, the gas inside the tank was inert gas with a less percentage of oxygen. But when you start ventilation, the oxygen is increasing. Before was the 8%, now is 10, 11, 20, and as much you ventilate the tank, the percentage of the oxygen is increasing, and so you have a risk of explosion. So how to avoid it? The first of all, before start gas freeing, you need to ventilate and push away by inert gas. By inert gas, you need to push away the carbon gases. And switch off the microphones, please, everybody. So you pushing inside the tank the IG inert gas with a low percentage of oxygen until you will get the 1% only of the gas. So when you have 1% of these gases, carbon gases inside the tank, in this case you are free, you don't afraid to ventilate it by fresh water. So even 10, 12, 15, 20%, no any risk. So gas freeing must be done very, very carefully. So because of gas freeing, during the gas freeing, the air is passing through the pipes, charging by electrical power, yeah, electrical charge and going inside the tank and immediately will discharge. So many sparks happen inside the tank. And if there will be explosive atmosphere, it could be, you may have a big trouble there. So during tank cleaning, Inside in tank cleaning, I will show you later the video. The static electricity accumulates here and on the nozzles, it gets the sparks there. So be careful for it. There is a lot of precautions. Let me see if there is a video I would like to show you. Okay. So hold on a minute. I will show you a short video for it. Hmm.
Welcome to the onboard video training program of Carcass. This video will explain in simple terms the concept of static electricity and its effect on safe operations on board tankers. Static electricity is the result of charge separation, charge accumulation, and finally, charge discharge. The accumulated charge, if not allowed to recombine or flow to Earth, will lead to a discharge of the same in form of a spark. This, in turn, will lead to an explosion in an inflammable atmosphere. The bonding wire fitted inside the tank cleaning hose is for purpose of carrying the charge to the Earth and not allowing any buildup of charge at the nozzle tip of the tank cleaning machine. To avoid any accumulation of charge on the surface of the pipelines, all pipelines on deck are provided with continuity bands in way of the insulating flanges. The static charge generated on rubbing of the hands with other objects is generally not sufficient to cause a spark. All equipment, such as the UTI or MMC tapes, needs to be bonded before using the same in an inflammable atmosphere.
Okay, that is a short video. Now I will continue with them. And later on we will see the full video. I will continue. We will finish with this one. So tank cleaning. Next is the sampling and gouging. So when you are calculating the cargo, and it will not happen once per day, you have to calculate the cargo maybe several times per watch. So it's always to open the pipe, attach the pipe with the UTI, which we will learn later. UTI lowering down in this moment is risky for the explosive again. So that is a risk explosive. So we will see the video how the risky it is. Yeah. So that's tape can touch the liquid surface and can create the spark. So if there is explosive atmosphere, so that is a risk, yeah, to explode. Here is the static electricity accumulating cargo. Please remember this. It's the name of the product and how it accumulates. Yeah, how frequent ability to accumulate the electricity inside in this tank. Here, how to avoid the electricity. So the bending these wires are connected. So what's happened? When the charge is going here, it must go directly to the next pipe, yeah, the charge. Otherwise, it will accumulate here positive charge, negative is here, and could happen the spark inside in the pipe, yeah. If the pipe is empty with explosive atmosphere, that could be explosive there. Okay, let's see the video. Before to go there, I need that you will fully understand the danger of the explosive, the static electricity. So here, wait, I will start the video and we'll share it with you. Hmm, okay.
Welcome to the onboard video training program of cargo. This video will explain in simple terms the concept of static electricity and its effect on safe operations on board tankers. Static electricity is the result of charge separation, charge accumulation, and finally, charge discharge. Charge separation takes place when any two substances
I want to almost.
one another. This could take place in the clouds when water droplets move against one another, or on board vessels when our hands move against any surface, or inside pipelines when a liquid flows through them. This charge will then tend to recombine with the separated charge or find its way to the Earth. For some reason, if the charges do not recombine or do not find way to Earth, they tend to accumulate on the surface of various objects. This accumulated charge, after some time, may then discharge in the form of a spark. Let us now examine some operations on tankers which pose serious threat to safety due to static electricity. As the cargo flows through the pipes and enters the tank at a fast rate, the cargo carries with it the charge, and this turbulence on entry into the tank causes a mist to be formed. This charged mist deposits the charge on sharp ends inside the tank, such as the nozzle of the fixed tank cleaning machine, high-level alarm probes, or any other sharp structures inside the tank. This is particularly evident for static accumulated cargoes, such as white petroleum distillates like kerosene, gas oil, and naphtha. As the tank cleaning water enters into the tank through the fixed tank cleaning machine, the separated charge accumulates at the nozzle tip. Even when portable tank cleaning machines are used, there is an accumulation of the electrostatic charge at the nozzle tip. Static accumulated cargoes, such as kerosene or styrene monomer, do not allow the accumulated charge to be earthed rapidly. Hence, any introduction of metallic objects, such as sounding bob or sampler, could lead to a static discharge. When steam is introduced into a tank, this leads to a rapid accumulation of static charge at the discharge nozzle or hose. The accumulated charge, if not allowed to recombine or flow to Earth, will lead to a discharge of the same in form of a spark. This, in turn, will lead to an explosion in an inflammable atmosphere. Now let us see the precautions we need to take for preventing any explosion or hazard occurring due to static electricity. If the tank is not inerted at the start of loading of cargo, the loading rate should be kept at a maximum of 1 meter per second till such time the loading pipe is not submerged, to allow the generated charges to recombine or flow to Earth. If the tank is not inerted and the vessel is loading static accumulated cargo, the bonded ullage bob or the sampler should not be allowed inside the tank for a period of at least 30 minutes after the cargo loading has been stopped.
I guess that is enough. It's a longer video. If somebody wish, I can share it with him. And that's is really showed you the risk, which is concerned, which is linked with the static electricity. Okay, but that is not only one, and we have to follow. So again, I would like to point you your attention. That's what is the risk, how to prevent it. So, like in this video, the showed when your tank is not inerted, when your tank is smaller than 3,000 cubic meters, and which is not compulsory for inerting, you just start loading with the only 1 meter per second rate of the loading rate must be 1 meter per second. Now, all the bonding wires must be connected to the bond, and it is also important when you finish your loading, you have to wait 30 minutes, 30 minutes, just to discharge of accumulating cargo. Yeah, only after the 30 minutes you can go and make allergy or sampling. Okay, now let's continue with our lesson. Here we have another problems on board the vessel. Toxicity. The toxicity, that is the that's toxic. Toxicity produce some cargoes, and that's a different way how to harm the human's body. And we have a different toxicities. We have a chemical, biological, and physical toxicity. But for us, is most important, of course, is the chemical toxicity. Yeah. So how it can damage the body? It's three roads how to can how you can be suffered by the toxicity. Oral toxicity, dermal toxicity, inhalations. Oral, when you just swallow it, that's mainly not necessary to drink a chemical from the tank. Sometimes during cargo operation, I have seen it myself when the man fell down and he start to, uh, without continuous, he start to breathing by the liquid, and of course he was swallowed some of the cargo. That was the toxic, oral toxicity. Dermal toxicity, that's because of your lack of attention. You just put your hands without gloves inside in the pipes where to take the samples or something, and the chemical you know, can be appeared on your hands or in your body. And there are few different cargos, chemical cargos like phenol. When you have only 5 square centimeters, this piece, if it will be on your skin somewhere, not on the hand somewhere, it's a guaranteed death. So you will die immediately. So that is a dermal toxicity. Inhalation. Inhalation when it's evaporated, the toxicity, and you're just going and you breathe this, and you sometimes you even don't feel that you are breathing the toxicity. So that's an important thing to take care about yourself. Next, that is how the toxicity appears. Reactivity. That is also important thing. Some of the cargo are self-reacting chemicals. Some of the chemicals are reacting with oxygen. Yes, it's some type of the cargo like propylene oxide. When it just has a leakage of inert atmosphere, and the air, normal air, that's common air which we are breathing, ambient temperature is going inside the tank, and they are touching each other, they explode immediately. So that is the self-reacting cargoes. Chemicals which react with the water, such like sulfuric acid, when the uh, sulfuric acid to connecting with the water creates a big temperature and explosion and creates a pressure. So that is also reacting with the water. So it's probably one of the bad situation when you don't you feel danger. You start washing the tank with the water, and this water going inside the tank, and there is the traces of the previous cargo, and that's happened immediately exposure, of the cargo. Many times it was happened on board the sulfuric acid carriers. Well, some of the chemical, as I say, is reacting with the O2 reaction, and here we must not to forget about the corrosive acid, nitric acid, sulfuric acids, and chlorhydric acid. So they are also very important just to care about them. So they are very corrosive cargoes, and they can damage and they can harm your body. Very quickly, I would like to concern you to just point your attention regarding the marple. Of course, you already passed the marple. Marple is you have a mark. It's finished with the marple environment, but in the chemical tanker, we must take care on the any tanker, not the chemical crude oil tanker. Also, we must care about the marple, about the environment protection. So just read it carefully, refresh your mind, and how it could happen. This is a situation when the vessel could spoil the environment. Yeah. So during the vessel stay in the port, could be leakage of the cargo arms, of the cargo hose, overflow during cargo operations. So you just forget to take care about the loading rate, and when the tank was filled up over the 95, 98% of going on deck here. Sometimes officers forget about it, and they just think, oh, we are discharging, nothing will happen. But discharge is going unstable and is going not on the shore, it's going to other tank fill it up. It also can have some pollution. Leakage in cargo piping system, that is also can happen. Malfunction of gouging equipment, yes, that was happened with me when I just trust to my equipment and that was not working properly, and we had some cargo appeared on deck. So that was a big trouble. Improper operation procedure, lack of control during cargo operation. Yes, when you are chatting with your girlfriend, don't taking care about alarms, and that could happen, could lead a bit for the pollution and very big trouble. Okay, when the vessel is at sea, it's also risky for pollution. Can be stranding or grounding or collision. So that could happen, could damage the hull and the cargo can go outside. So cargo transfer, yeah, that's also during STS. Yeah, so two vessels are in the middle of sea somewhere, transferring cargo from one ship to another one. That's calling operation ship-to-ship operation. And in this case, could happen also a lot of situation when it is risky for the pollution of the environment. Tank cleaning, yes, that is in the tank cleaning. That is not only risk accidentally pollution. Sometimes the people are specially doing some operation just to speed up the operation, just to speed up to do more faster. The tank cleaning, they are making the some harm. They are doing some operation which harms the environment. Thermal expansion. Yes, thermal could be happen when you loading 98% in Norwegian and the cargo temperature is at 5-7 degrees and you passing through the equatorial zone, the cargo starts heat up and the cargo starts exposure, expansion, and in one day you see the cargo is on deck. Yeah. And one of the bad situations when you need to make a jettisoning of cargo. Jettisoning, please remember this word jettisoning when you has not have that's it's especially write it here. So jettison of the cargo when you need to discharge the cargo overboard. So you are doing pollution by yourself. Yeah? So what to do if you need to make a jettisoning of cargo is listed here. You need to inform the engine room, So discharge should take place in the sea valve, so it's below this surface. So all non-essential valves to be closed, all safety precautions to be taken. A radio warning should be broadcast. You must inform all the vessels around. Jettisoning of cargo, it's a very bad operation, and I hope you will never do it. But in some cases, you have no other choice. Just to save your crew, you save your vessel, and the remaining cargo, you must to do the jettisoning. So again, it's a discharge of cargo overboard in order to prevent explosion or any emergency situation. And the jettisoning of cargo is an extremely measure, justified only as a means of saving life at sea or any or the safety of the vessel. So hope you will never have this situation to choose to make a jettisoning or to save the life. Okay, Marples, Annex 2, please take care about it. There are a lot of changes in Marple and what to do in the emergency of in situation of pollution. You must raise alarm, stop cargo operation, and activate ship's emergency plan, which call it SOPEP SMPEP, Ship Board Oil Pollution Emergency Plan. So I guess you already know about it. You already passed the Marpo, and so I will not stop a long time with this one because you have already learned. Next is the material safety data sheet, MSDS. Remember, MSDS is a document that is it is not the property of the cargo. No, it is not the original certificate. No, it's just information which you must know how to manage with this cargo. Not the cargo only, or liquid and any product. Even paint for bosun, when you're receiving the paint for bosun, it's going with MSDS. You cannot receive the paint without MSDS. You cannot receive the chemical for the washing, dishes washing, or for any engine chemical or anyone without MSDS. Of course, you cannot load the cargo without presentation of MSDS because MSDS contains very important information how to manage an emergency and also information which you need to know how to load and how to discharge. So total MSDS consists of the 16 section. I will just jump to the number 14 because it's for us, for the tanker vessels, it's very, very important. But just to remind you, all of the section, which first aid measures, firefighting measures, handling and storage measures. So sections is very important also. Explore personal protection. That is TLV, threshold limit value, and TW, TWA also is you must find in section A. But for us, is much more important the section 14 as for this lesson especially. In section 14, you will find MARPO Annex category, which is Annex 1 or Annex 2, the cargo. So depend of Annex 2 or Annex 1, you have to take measures and follow the tank. So you fill up in different oil record book, you taking care about it, you need um, do you need you find the information here, do you need to make a pre-wash or not? So that is everything is written here in the 14th section. And also IMDG code, which IMDG code and which is UN number, United number, which is a ship's proper ship's name, etc. You will find in the section 14. Remember it, that will be your question. So here, end of the lesson, I would like to share with you some questions, which will be your question on your exam and also on your final exam. You can take this list of these questions here and you can share it with your friends, no problem at all. So here, thank you very much for your attention. And if you have any questions, I can answer it to you right now. Please go ahead.
Hello. I want to ask when we'll start our second exams.
Second exam, let me see. Calendar. Second exam, we will part, so it will be 30 and 31 December.
All right. Thanks.
Welcome. Yeah. Exactly, yes. 30 and 31. It will be the same format. I will take by groups. You will pass this exam and finally, final exam Daskuniti, you will take, I don't know when. That's Gocha Chitizivish, will inform you. Or Ildar Skalets. Okay, any question regarding for the lesson which I had just passed? Not any questions. Thank you very much. I hope you understand everything. Thank you. All the best to you. Take care.